For Lesson 8's homework, Composition of Rigid Motions, we want to look at what happens when we put two or more of our rigid motions together. In the diagram to the right, triangle ABC is congruent to triangle DEF, so we know we're talking about translations, reflections, and rotations. Which sequence of transformations maps ABC onto DEF? So what we want to do is we just want to look at each choice individually, and let's see what happens. So the first one says a reflection over the x-axis. Well, that would put the first triangle here. Now notice it's upside down compared where it is to DEF, and then if we're just going to translate it over, well, it's still going to be stuck upside down, so we know that one's not it. A reflection over the y-axis, followed by a translation. So that would put us here, and then if we slid it down, well, that looks like it could be possible, so we're going to hold on to that one. A rotation 180 degrees around the around the origin, followed by a translation. Well, if we rotated it 180 degrees, that would make our triangle look like this. And it would basically be on top of it, but then there's no sort of slide that we could get so that they were on top of each other. And then choice D, a counterclockwise rotation of 90 degrees about the origin, followed by a translation. Well, if we did that, that would be our triangle. And again, there'd be no slide that would get it over. So we're looking at choice B as our answer for that one. I'm just going to quickly redraw that triangle that if we reflected it over the y-axis we would have, so that this way it works nice and easy. In the second one, the coordinates of ABC are A -1, 1, B -5, 3, and C -2, 7. Graph and state the coordinates of triangle A double prime, B double prime, C double prime. The image after the composition T -5, 1, composed with a rotation around the origin of 180 degrees. Now, we have to remember that we always work from right to left, so we have to do our rotation first. And although it doesn't want the single prime coordinates, I usually always write them. So our first one is A11, 1, B -5, 3, and C -2, 7. And we're going to look at what happens first when we do our rotation about the origin of 180 degrees. So we'll focus on that piece first. I'm going to start by plotting my original one. So there's A, 1, 2, 3, 4, 5, 3. There's B, and -2, 3, 4, 5, 6, 7. So there's C, B, and A. We'll make our triangle. So for the next piece, we're going to end up with A prime, B prime, and C prime, and that's going to be our rotation. You could turn your paper, you could remember the rule, it's up to you. But we're going to end up with A at 1, -1. We're going to end up with B at 5, -3, and C at 2, -7. So if I plot those points, 2, 3, 4, 5, 5, -3, and 2, -7. So there's A prime, B prime, and C prime. But again, remember, they really don't want those points. Okay, those are only our intermittent points because we still have to do our translation of -5, 1, which means we're going to go all points to the left 5 and up 1. So 1, 2, 3, 4, 5, and up 1. There's our new A prime. 1, 2, 3, 4, 5, and up 1. There's our new B prime. And 1, 2, 3, 4, 5, and up 1 is our new C prime. And what do we end up with there? Hopefully your line's a little bit straighter than mine there. So for A double prime, we should end up with -4, 0. B double prime, we should end up with 0, -2. And for C double prime, we should end up with -3, 1, 2, 3, 4, 5, -3, -6. And those are going to be our coordinates for our double prime shapes. What are the coordinates of A prime, the image of A, -4, 1, after a composite transformation, a rotation 90 degrees composed with a reflection y = x, where the origin is the center of rotation? So the first thing we have to do, we'll take -4, 1. again, we work from right to left, so we're going to reflect it over y equals x, which means we're going to end up flipping our coordinate and we get 1, negative 4. Then we will rotate it, and it's set about the origin 90 degrees. So remember, it's positive, so it is clockwise. And that is going to give us our final point of, again, up to you. If you remember our rotation about the origin 90 degree rule, we had x, y, led us to negative y, x, or you could just use some scrap graph paper and plot it from there. And we end up with 4, 1, or choice 4. We're going to do basically the same thing in number 4. We are just going to do it to an entire triangle now. So we'll start out with our original points, J, 1, negative 2, R, negative 3, 6, and B, 4, positive 5. So the first thing we want to do, again, we work from right to left, so we're going to do a reflection y-axis. Okay, so that's going to give us that J prime is going to be, now remember, when we reflect across the y-axis, we change the sign of our x coordinate, so negative 1, negative 2. Then we get 3, 6, and our final piece, B prime, is going to be negative 4, positive 5. So that's what it looks like when we reflect over the y-axis. Then when we take all of them again and we translate them to negative 1, we're going to end up with J double prime, our final coordinate, as positive 1, negative 3. R double prime will end up with 5, 5. And for B double prime, we're going to end up with negative 2, 4. Now I got those by adding 2 to all the x's and subtracting 1 from all the y's. But again, you could also just put it on some scrap graph paper and move everything to the right 2 and down 1. And that leaves us with choice 3 as our answer. And for the last one, describe a sequence of transformations that will map triangle ABC onto DEF. Now remember, you have to make sure you read these in order. So this is our start, and DEF is our finish. So you want to make sure if you're sliding or reflecting or rotating that you're starting in the correct place. Now to me, it looks like that if I take triangle ABC and I reflect it over the x-axis, that's going to put my points here, here, and here. So that would be like an A prime, a B prime, and a C prime. And then if I look, it just seems as if it's a simple translation to the right that will help us out here. So, a reflection over the x-axis followed by a translation. And it seems here that we have to go 1, 2, 3, 4, 5, 6. Now notice, A matches up with D, B matches up with E, and C matches up with F. So I want to make sure that I'm matching up my letters correctly, which is why I counted from the A prime to the D. If you count B prime 1, 2, 3, 4, 5, 6 to E, and C prime 1, 2, 3, 4, 5, 6 to F. So remember, first letter with first letter, second with second, third with third, third with third. So then we're going to be a translation, 6 units right. Now this transformation actually works in the opposite direction. If you translate it to the right 6 and then reflect it over the x-axis, this one works as well. If we wanted to write it in composition notation, we would write a translation 6, 0, composed with a reflection over the x-axis, and we're doing it to triangle ABC. And again, if you had the order switched on that for this particular problem, that will also work.